Alright, so this is going to be basically the first thing they see when they come in here. We're going to pretend, I'm going to do the intro here, and then I'm going to jump over and help people set this up. Hey everybody, my name is Calvin, and welcome back to my channel. Today, I'm going to be teaching you all about LaTeX. What is LaTeX? LaTeX is a tool for creating clean and professional looking documents. It's commonly used for research papers, resumes, reports, academic assignments, technical documentation, or just anything that needs strong formatting features. It's a bit different than just dragging things around in Microsoft Word or Google Docs, because LaTeX will let us write instructions for how the document should exactly look. In this video, I'm going to be teaching you how to get set up with LaTeX, and also creating your first document inside Overleaf. Before we jump in, I have a message I'd like to share with you. Also, real quick before we jump in, if you've been enjoying the content on this channel and want to support what I'm building here, check out my book Modern Data, From Ingestion to Production. It's a practical introduction to how data moves through modern systems, from ingestion and transformation all the way to production use. It's available on Amazon, Barnes & Nobles, and Apple Books, and the ebook is only $6, so it's a really affordable way to support the channel and learn something useful at the same time. Be sure to check out the links in the description. A little bit more about LaTeX. LaTeX, specifically, is a document preparation system. That means we can write plain text with commands, and then LaTeX will turn that into a properly formatted document. For example, instead of highlighting text or clicking a bold button like you would in Google Docs, we'll write a command instead. So LaTeX will feel a little bit like programming, but instead of building an app, we're just building a document. And that's why LaTeX is especially useful for technical writing, like research papers, and it handles things like equations, citations, tables, figures, section numbering, and formatting. Now, let's set up Overleaf. Overleaf is an online LaTeX editor. The nice thing about Overleaf is that we do not need to install LaTeX locally on our computer like we would have to with Python. So, in your browser, your favorite search engine, look up Overleaf and click on www.overleaf.com. When you click on, you'll see something like this. Here, you're going to want to create a free Overleaf account. You can do this with your Google account or your Orchid account or just your email and password. If you don't know what Orchid is, that's fine. It's basically a unique identifier that you sign up with, and so everyone in the research world knows who you are using that ID. But that's not the point of this video. So go ahead and sign up. I've already signed up, so I'll just have to log in. When you sign up, you'll be greeted with a screen that looks something like this. This is the project dashboard, and this is where all of our LaTeX projects will live. Think of a project like a container of sorts. It will contain your main file, images, bibliography files, and any other supporting documents that your document needs. Let's go ahead and create our first project. Go ahead and click Create a New Project, Blank Project. And for this project, I'm just going to call it Tutorial. But you can call this project whatever you want. Go ahead and hit Create. Now, we're inside the Overleaf editor. The left side right here is going to be where we write our LaTeX code. You can see it's already been seeded with a couple of commands. On the right side is where we'll see the compiled PDF preview. You can see that our main file is called main.txt. And this is the file where our LaTeX code will go. This is nice to have to start off, but for tutorial's sake, I'm going to start from scratch. Let's write something like this. I'll do a / document class, and then squiggly brackets with article in it. And this will tell LaTeX what kind of document we're creating. In this case, we're creating an article. And the article document class is commonly used for shorter documents like homework assignments, reports, essays, and papers. Next, we'll do / begin document. Again, in squiggly brackets. And this here will tell LaTeX where the actual document content begins. And here we can write some text in this block. For example, we'll type hello LaTeX. And this is the text that will appear in the PDF. And then finally, we have our end here. And this was created when we created our \begin. And this is basically the opposite of begin. It's going to tell LaTeX where the document ends. You'll see that we still have our code from before. That's because we'll need to recompile this PDF. And we can do that by clicking recompile. And this here will recompile the code in our code editor. And now our changes are reflected. Let's talk about an important LaTeX concept, and that is the preamble. The preamble is the setup area before the document begins. In our example, remember that this part is the preamble, our \document class. This is where we define the document type, import packages, set margins, configure fonts, and prepare anything that the document needs. A package is like an add-on. It gives LaTeX extra features. For example, say we wanted better control over the margins. We can use the geometry package. Here, before we do \begin, we'll add some space. And here, we'll write the command \use package, a square bracket, margin is equal to 1 inch, and then squiggly bracket, geometry. And this line here, we'll load the geometry package and set the paper margin to 1 inch. The geometry package here is one of the most common packages you'll see in LaTeX documents. Let's go ahead and recompile our code. And you can see that our document updated. Let's go ahead and make our document look a little bit more official. Let's add a title, an author, and a date in the preamble. Here, we can just use the title, author, and date command. So \title, squiggly brackets, my first LaTeX document, and we'll do the same thing for author, \author, squiggly bracket, Kelvin Lin, and we'll also put in our date, and this is how you would do that, \today, and here we've set it our title, our author, and the date. This line right here sets the title, my first LaTeX document. Right here, we'll set the author, that being me. And now here, this /date/today in here is a little bit different because we have another command within /date. Our \today command will automatically insert today's date. So we'd get today's date, and then we would set the date to today's date. And let's run this. Nothing changed over here. That's because we need to add in a separate command to let LaTeX know that we want to display the title. To do so, we'll do \make title. And now let's recompile. And now you can see that we have our title, our author, and we have today's date, or whatever date you'll be following this tutorial at. Let's add some structure to our document. In LaTeX, we can create sections using commands like section, subsection, and then subsection. Here, to make it make more sense, I'm just going to move make title into our begin document class right here. Recompile that. There we go, and that's fixed it. And that fixed our little centering issue right here. The make title should be within your begin block. Oops. Now let's get rid of our hello LaTeX. Let's say we wanted to create an introduction section. And we can define the introduction section by using the section command. So it's as easy as doing \section and then our squiggly brackets, introduction. And in here, we can write our introduction. Hello, welcome to my document. This is my introduction section. And now let's say we wanted to define a class called background. Same thing. We'll just do this again, and then we'll put background in the squiggly brackets, and then do LaTeX is useful for writing technical documents, research papers, Say we wanted to have a subsection called Why Use LaTeX, and we can do something like subsection, squiggly brackets, Why Use LaTeX. LaTeX gives us precise control over formatting and works well with equations. And let's add in our conclusion section right here, and we'll just do the same thing. Conclusion. And we'll type something like our document is concluded. Now, let's recompile. And you can see that these commands right here have made it onto the PDF. Notice that LaTeX will automatically number the sections for us. We didn't manually type 1 introduction, 2 background, 2.1 why use LaTeX, and 3 conclusion. LaTeX handled that automatically behind the scenes. It's one of the big benefits of LaTeX, in that it'll manage structure for us. Let's talk about paragraphs. In LaTeX, a new paragraph is created by leaving a blank line between blocks of text. Say we wanted these 2 sentences to be in their own paragraphs. You can see that they're all just in this one line right here, but what if we wanted to have them in separate sections? It's as simple as just leaving a blank line in between and recompiling. Let's do some formatting of text. To make text bold, we can use the textbf command. Say we wanted to bold hello welcome to my document. We would do \text bf and then put the text in our squiggly brackets right here and recompile. And this will be bolded. And the same thing and the same idea for italics / text it this time. And we can do something like that. And this is now italicized. And to underline text, we can also use the underline command. And say we wanted to underline this line of text right here. We'll do \, underline, and then squiggly brackets, recompile. You can see that's reflected in our document now. And you should start to see the pattern now. A LaTeX command usually starts with a \. Notice it's not the /. Then we have the command name. Then we put the content inside squiggly brackets. Like any programming language, LaTeX will also support comments. A comment is text that LaTeX will ignore. To write a comment, we can use a %sign. So we can start our comment using the %sign right here. Hello, this is my comment. Here we can see that we've defined a comment right here, and this should not appear on our LaTeX document. Let's recompile, and we see nothing. Do the same thing if we took this and put it in here, recompile, and nothing. Comments are useful for leaving notes to yourself or whoever else you might be collaborating on the document with. They're also useful when you want to temporarily remove a line without deleting it. Say we wanted to see what our document would look like if we didn't have the subsection. We can recompile this. Now, we ignore this command right here. But of course, we don't want that, so we'll put this back. Now, let's work on some lists. There are 2 common types of lists in LaTeX, unordered and ordered lists. An unordered list uses bullet points. In LaTeX, we can create it with an itemized environment. Right here, let's begin. Let's say we wanted to add a list right before background section. We can do \begin, squiggly brackets, and then we'll put in the keyword itemize. And it'll give us something that looks like this with \item. And here we can begin adding in our items. Say we wanted to have an item called create an Overleaf account. and then another item, start a new project, and then another item, write LaTeX code. And now we can recompile this. Let's see what it looks like. Huh, there we go. Now we have bullets. What if we wanted this to be numbered though? Here, we'll just use the keyword enumerate. So, take out itemize and insert enumerate. Oops. Might be easier to create a new list actually. Define it the same way. Take and we can borrow our items from up here. And let's recompile this. Whoops, looks like there's a typo here. Look, an account. Create an Overleaf account. That's what it should say. Recompile this. As we touched on before, one of the biggest reasons people will use LaTeX is its math. LaTeX is very good at formatting equations. There are two common ways to write math in LaTeX. First being inline math, and second being display math. Inline math appears inside a sentence. For inline math, we use dollar signs. For example, in our introduction here, let's do the formula for area is, and then dollar sign A is equal to length times width, dollar sign. And this will put the equation directly inside this paragraph. We'll compile this. Now you can see this is what the formula will look like. And this is how you would see it in research papers. Display math appears on its own line. For display math, we can use backslash square brackets. A is equal to length times width. And then right here, we compile this. And you can see that we have created display math. Let's move this into a math section. Here we can define a section called basic math, squiggly line, basic math. And now let's touch on exponents and fractions. We can write exponents pretty easily. Here we'll do some display math, define it like we did before. And here we're going to do something like x squared plus y squared is equal to z squared. And here, all we're going to be using is the caret. And the caret, right here, will tell LaTeX that this is an exponent. Let's compile this. And we can see that now we have the Pythagorean theorem, like you would see it in a research paper. Let's do the same thing for fractions. Define it. And here, fractions are a little bit different. We'll do backslash frac, the frac command, and then 1, and then 2. And what this will do right here is this command right here will create a fraction with 1 as the numerator and 2 as the denominator. And we can do something like 1/2 plus frac 1/4 is equal to 3/4. Let's compile this. And there we go. Let's create a simple table now. Tables can look a bit intimidating at first, But the basic idea is not really that bad. Let's begin by defining a simple example here. Say after this, we wanted to create a table, and we'll use the begin command like before, like we did with our list, but this time we're going to be using the tabular command. And we'll add another straight line here. What we have here right now is this CCC right here tells LaTeX that we want 3 centered columns, and the C here means centered. The vertical bars create vertical lines between columns. Here, we'll do each line, and what this will do right here is create a horizontal line. Inside the table, we want separate columns with ampersands. We'll do name and course and grade. And we end each row with 2 backslashes. I'll move this for now. And then we can do another horizontal line. And here we can do LS in column 1, math in column 2, and an A in column 3. And then we'll add another horizontal line. So let's recompile this. Let's move the table into its own section. Section, table. Again, notice how our section numbers automatically update, even though we didn't do anything. Now we can see our table right here. Now, what if we had an image or a graph that we wanted to put into the document? It's not as simple as just going copy and paste. First, we'll want to get our image. We can do that by going up to here and hitting and selecting the file that you'd like to upload. And this can be some kind of image. Here, I've uploaded a PNG called LaTeX. And this is what it looks like. We can examine it right here, and we can also download it if we want, but we want to show this LaTeX PNG in our document. To include images in LaTeX, we usually need the GraphicX package. Go back to the preamble, and we'll have to import that package. We'll use package, and then we'll define GraphicX. And this will allow us to use images in our document. And now we can go ahead and put in our image. Here, let's create another section, and we'll call it image. Keep things nice and separated. And we can define it by doing begin, center, and then we'll do / include graphics, and we can define it width is equal to 0.5 / text width, and then we'll put in our sample image, which is this LaTeX PNG. If it recognizes it, it'll auto-populate right here. And now, let's hit recompile. And there we go. By defining the width here to 0.5, we're basically telling LaTeX that this image should be about half the width of the text area. If the image is too big or too small, we can just simply change this number. Let's say, what if we thought this LaTeX PNG was a bit too big? All we would have to do is lower this number down to 0.2. And you can see that now our LaTeX picture has shrunk. Now we have our complete exercise document. Now we want to take this document and share it with people. We can do this by going to download right here, download PDF, and downloading it to, and we can go right here and click on this, and this will download this PDF onto your machine. The .text file is the source code, and the PDF is the final output. And that's the basic workflow for writing LaTeX within Overleaf. In this video, we created an Overleaf account. We started a new project, wrote our first text file, and learned the basic structure of a LaTeX document. We've covered sections, formatting, lists, equations, and tables. At first, LaTeX can look intimidating, but if you break it down into small chunks, it really isn't. Once you get used to it, LaTeX becomes very powerful, especially for technical and academic research documents. Thanks for watching, and I'll see you guys in the next video.